Number 1, a curve is described by the parametric equations x equals t squared plus 2t and y equals t cubed plus t squared. An equation of the line tangent to the curve at the point determined by t equals 1 is which one of those choices below? Alright, so it's asking us for an equation of a tangent line. So I know an equation of a tangent line, I need y equals mx plus b. And to get m, I know that I need to find the derivative. So I need to find dy dx. And if you recall, to get the derivative of dy dx when we're in parametric, it's going to be y prime over x prime. So y prime will be 3t squared plus 2t, and then divided by x prime will be 2t plus 2. And we would like the derivative at t equals 1. So dy dx at t equals 1 will be 3 times 1 squared plus 2 times 1 over 2 times 1 plus 2. If I work that out, I will get 5 over 4. So I just found out that my m is equal to 5/4. Alrighty. Okay, so now I need my x and my y value. Well, when t equals 1, x is going to equal 1 squared plus 2 times 1, and that will be 3. And then y will equal 1 cubed plus 1 squared, which will be 2. So the point is 3, 2. So now my y value is 2, my x value is 3. So I'm going to have 2 equals 5/4 times 3 is 15/4 plus b. And then I will subtract 15/4 from both sides. And when I do that, this is actually 8/4. So 8/4 minus 15/4 is negative 7/4. That will be my b. So my equation is going to be y equals my m, which was 5/4 x minus 7/4, and I notice the equations don't match what I have. So first of all, I'm going to clear the fraction by multiplying through by a 4. So now I'm going to have 4y is equal to 5/4 x minus, just 5x minus 7, so I'm getting closer, and actually I can tell it's choice D, but I'll just make sure now. I am going to subtract 5x from both sides, so I'll have negative 5x plus 4y equals negative 7, and then I'm going to multiply the entire equation by negative 1, which gives me 5x minus 4y equals 7, which is definitely choice D. Alright, next. If 3x squared plus 2xy plus y squared equals 1, then dy dx equals what? And I notice dy dx is the derivative, so we are going to have to take the derivative. I will need to use the product rule on this middle part, so I'm going to go ahead and get this set up. F prime will be 2, and g prime will be dy dx. So I'm ready to take the derivative. The derivative of 3x squared is 6x, plus the product rule here will have f prime times g, which will be f2 times y, plus f times g prime, so 2x dy dx, and then plus the derivative of y squared will be 2y dy dx, and then equals the derivative of 1 is just 0. So keeping my dy dx's on one side and everything else to the other side, we'll get 2x plus 2y, 2x dy dx, step ahead of myself, plus 2y dy dx will equal negative 6x minus 2y. I'm going to factor out a dy dx. 2x plus 2y is equal to negative 6x minus 2y, and then I'll divide both sides by 2x plus 2y. So now I will get dy dx is equal to negative 6x minus 2y over 2x plus 2y, and to get my answer to match one of theirs, I am going to factor out what I can. In the numerator, I can factor out a negative 2, and when I do that, I will get 3x plus y. And then in the denominator, I can factor out a 2, and I will get x plus y. And negative 2 divided by 2 will give me negative 1, so this is going to be negative 3x plus y over x plus y, and that is choice B. So we got it. B is my answer. All right, number 3. The table above gives selected values for the derivative of a function g on the interval from negative 1 to 2. If g of negative 1 is equal to negative 2, and Euler's method with a step size of 1.5 is used to approximate g of 2, what is the resulting approximation? So let's get set for Euler's method here. My initial x and y they gave me was negative 1, and my y value is negative 2. right? It told me to use a step size of 1.5, so if I add 1.5 to the negative 1, I will get 0.5, and then if I add 1.5 to that, I will get 2, and that's exactly where I need to be, so it looks like a two-step problem. So we will come over here for step 1. We'll have y prime is equal to delta y over delta x. To get y prime in this case, we are just looking for the derivative at x equals negative 1, and the derivative at x equals negative 1 is 2. So I'm going to have 2 is equal to delta y over the change in x, which is 1.5. Cross multiply, we'll get delta y equals 3. So I will add 3 to my y value, and that will give me 1. And then my second step, we'll get y prime is equal to delta y over delta x. And so on this one, again, my derivative at 0.5 is equal to 1. So we'll get 1 equals delta y over the step size again, which is 1.5. So delta y cross multiplying is 1.5. So I get to add 1.5 to my y value, and I get 2.5. So my answer is D. All right, number 4. What are all values of x for which the series of n to the 3n, n times 3 to the n over x to the n converges? All right, so I know I'm going to be using either the ratio test or the root test, and I think I will use the root test actually because I think it will be a little bit easier. Okay, so if I use the root test, I'm going to be finding the limit as n approaches infinity of the nth root of n 3 to the n over x to the n, which will give me the nth root of n times 3 over x, and then I know the limit as n approaches infinity of this part right here is going to be 1, so my limit is going to equal 3 over x, and I know using the root test, I need the absolute value of 3 over x to be less than 1. And at this spot, we are used to not having an x on the bottom. We are used to having a constant on the bottom. So at this point, I'm looking at my answers, and all the answers are kind of weird. So I just started thinking about what my x would have to be. If I want this number inside to be a number that's less than 1, my x is going to have to be bigger than 3. And it's going to have to be the absolute value of that x is going to have to be bigger than 3. So I jumped immediately to choice D, because all the other ones would be less than 3. If x was less than 3, this answer would not be less than 1. So that's how I chose D for that answer. All right, problem 5. If the derivative of f of x is equal to g of x, and h of x is equal to x squared, then the derivative of f of h of x is equal to what? All right, so I'm going to do a u substitution here. I'm going to let u equal h of x. So this is going to be f of u. So if I take the derivative, I'm going to get f prime of u, and then times the derivative of u, which is du. Okay, so let's see if we can do this. We'll get f prime, I let my u be h of x, and then the du is going to be the derivative of h, which would be h prime. So when I do this, I'm going to get f prime of h of x is equal to, well, I'm going to do a couple things here. Okay, so I'm going to have the derivative f prime of h of x. Well, we know that h of x is equal to x squared. And then h prime of x would be the derivative of x squared, which would be 2x. Okay, and now this says to find f prime of x squared. So we know that the derivative of f is g. So instead of having f prime, I can have g. So it's going to be g of x squared times 2x, and that leads me to choice D. Okay, problem 6. If f prime is a continuous function for all real x, a slope field on there for some reason, sorry about that. Okay, if f prime is a continuous function for all real x, then the limit as h approaches 0 of 1 over h times the integral from a to a plus h of f prime of x is equal to what? And this looks like just a crazy, weird problem. I noticed something about a limit, so I just thought, what can I do here? I do also notice that I'm taking an integral of a derivative, so I'm going to just try to simplify that and see if I can get this to look like something. So I've got the limit as h approaches 0 of 1 over h, and then the integral of the derivative of f prime would just give me f, but I would have to evaluate it at a plus h, and then minus the limit at a. Okay, so if I rewrote this problem, so I'm going to put a 1 under here, then I'm going to multiply the numerators and multiply the denominators. I get the limit as h approaches 0 of f of a plus h minus f of a all over h. All right, hopefully you are noticing that that looks very familiar to finding the derivative. So we've got the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So if you'll notice that this really is an exact, pretty much an exact match. So this basically is just asking me for, if you see a limit like that, it's just actually saying find the derivative of f. Okay, and instead of, we'll use f of a because this is an a instead of an x. So basically the derivative of f of a is going to be f prime of a, which is choice E. So that was a derivative problem, definitely in disguise. All right, we've got a slope field going on here. The slope field for a certain differential equation is shown above. Which of the following could be a specific solution to that differential equation? So if I'm given a slope field, it actually shows me what the solution is going to look like. So if I try to draw what this is going to look like, I'm just trying to follow the pattern. I know that that graph specifically looks like a natural log function. So I'm going to go right to y equals e ln x because none of those others would fit that pattern. So it is going to be choice E.